Thank you. So to start off, I'll share the link to the docs that I'm going to be talking through in case anyone wants to follow along. I'll also share my screen just so people have it for reference later on if you want it. Can you see this page saying OpenShift?
Yes, it's still coming into focus, but yes.
Okay. Luckily, I've shared the link, so if it's blurry, you can just open the link and follow along. I'm sure you'll be able to see kind of where I am. Cool. Today, I'm going to be talking about deploying the various components of ecosystem AI in an OpenShift environment. Depending on how much you know about Kubernetes and OpenShift, it's pretty similar to the Kubernetes environment, which we spoke about at the end of last year. The differences come about with OpenShift's kind of security policies. So what this approach allows you to do the deployment without changing any of OpenShift's default security policies. You don't need to grant the service account any additional permissions to run the setup. As I'm talking through it, I'll point to the pieces of functionality where we do that. That's the main difference between those two environments. Networking, OpenShift uses the roots functionality. Kubernetes depends on the implementation that you're using, how you'll get access to the endpoints that get exposed. Those are the only real differences between OpenShift and Kubernetes for what we are doing. So you can, if you want to test locally, use CRC, which is the dev version of OpenShift. We're going to be using the OC command line tool. You'll need to have that installed before you do this, in the same way that you'd use kubectl for Kubernetes. This assumes that you have authenticated to your OpenShift instance and set everything up so that you're working in the right namespace and all those things. Projects are in OpenShift. So we're going to talk through a couple of sections. The first will be setting up the high-level environment variables, creating your persistent volume claims, the server deployment, the notebook and Grafana deployments, then the Workbench and Runtime deployments, and then some notes. Depending on where we are with time, we can also talk about pushing deployments from the runtime, but that might end up being another session. You can see in this link, there's a number of environment variables that influence the behavior of the ecosystem AI system. And one of the ways given a few ways you can set them here depending on your environment. But in this OpenShift case, we will create a config map with our environment variables that we want, assuming you have a secret created with your license key. Then you'll see that being referenced in the deployment files. So the way the rest of this is structured is we have the YAML to create the OpenShift configuration and then the commands to use that YAML. The commands are pretty simple. It's kind of, in this case, OC apply the file, and it's assuming that you've saved this as ecosystem config map.yaml. We set our server variables, report the server IP. So whatever your routing default is that's being set up in OpenShift, you can work out what name is going to end up being generated here, or you can specify it if you want. We're going to mount a properties file, support, and we don't want the Workbench spun up in the server. For the runtime, we're going to set our monitoring delay and run our port, and we're going to have a Mongo running in the server that the runtime is going to use. You can also put in your route that the server is going to be deployed at, so that the Workbench can point to it in the port. And then we have a couple of properties. I'm not going to go through kind of all of these again. You can check in the other documentation, but the idea is that you can set up your environment variables here. You apply your config map, and that will store this config map in this case, we're working in the ecosystem namespace, but whichever namespace you want to work in, this config map will then be created there and stored there along with your license key secret. The next part is persistent volume claims. So This is obviously to allow you to store data between restarts, which is quite important. So you need to have these PVCs created. Ideally, you should have a read-write many persistent volume claim, as it makes management across the different components easier. The ideal case is we'd create an ecosystem data volume, and that would be mounted to all of your Run server and notebooks so that they can all share data across themselves, and you can view logs for the runtimes in the server and all of those things. If your OpenShift instance doesn't support read-write many PVCs, then you either need to give up that convenience of management, or you can try and force all of the pods to start up on the same node, but that's kind of risky for a bunch of reasons and can be a bit complicated with managing resources and all of those things. So if you have a very simple environment where, say, you just have one Kubernetes node, then obviously it doesn't matter. But generally, you should try and have a read-write many persistent volume claim. And if you can't, that's what we're going to show here. If you can't do that, the best approach is to create multiple persistent volume claims and have each deployment mount its own persistent volume claim. If you want to logs, you'll have to go into that specific pod, or if you want to share data, you'll have to copy it between them using some other approach. So we've got our read-write many persistent volume claim in the ecosystem namespace, and you can give it whatever size you need. This can vary a lot depending on the big determining thing is, are you running Mongo and your kind of database functionality inside this server, which in this setup example we're doing. In that case, we need to make sure we have enough storage for the data that we want to ingest for our use case. Probably when you have a more mature production type environment, you'd have a separate Mongo instance and separate database instances. The storage for your ecosystem components would not need to be as high because running the database in the server pod. If you are storing the data, it obviously depends a lot on the use case, how much data you need to store. So it's not really possible to specify this generically. It depends a lot on the case. And then we have, again, now very simple OC apply ecosystem pvc.yaml. So then we get into, now that we have our environment variables and our persistent volume claims, we can start creating our deployments. There's a couple of notes here. So the first is you'll see the images specified here are all pulled from Docker Hub directly. Generally, you would rather want to have some sort of local repository in your environment where you put the images and then pull them from there. So that's something that you would generally want to edit. Obviously, we don't know what your local repository looks like, so this is a version that will work, but it's better to have some sort of local repo. We also haven't specified resources because, again, that is specific to the environment. So you would want to add that to each of these based on the specifics of the implementation that you're looking at. So here we have our server deployment config. So we're creating our ecosystem server deployment in the ecosystem namespace. We're creating a single replica. Generally, the server is not something you will need to worry about scaling. So, you can have multiple replicas if you want to, but it's generally not necessary. Then we're going to get our ecosystem server image. You can get the tag based on the architecture that you're deploying into. And then we have our environment variables. So here we reference this master key will be the secret you've created with your license key. This assumes that you've created a master key secret that will have this value here. And then we get a bunch of different environment variable values from our ecosystem in config map. So we get our port, our server IP, where the property file is, all of those environment variables that we then expose a few ports. 3001 is the endpoint for the APIs for the server itself. That's to be something else with this port environment variable. 54321 is the default for the H2O instance that will be spun up in the server. You can turn that off, but you could have a separate H2O environment running that you use. But here we have it bundled in with the server. So that will be our H2O port. And then 54445 will be our Mongo port, where we can access the Mongo instance that is spun up as part of starting up the server. And then we mount the volumes, both of them. So we mount our ecosystem data PBC, and then at the data subpath, we mount /data, and server config subpath, we mount /config. So this will store any config changes we make between restarts. This will be our general data storage, and also contain the Mongo collection files. Once you've set up this server deployment, added the resources, and changed this to point to your local repo, you can then run the commands to set that up. So you'll see there are a couple of additional things here. It's actually only one additional thing, but it's in a few lines. So we've got our apply of our server deployment on OpenShift, and that will then take this deployment file, create the deployment, and spin up a server pod. And then we do OC expose deployment, ecosystem server, and then we go through each of these ports that we've opened here in our deployment. So we exposing our 3001 port, our 5445 port, and our 54321 port, calling them server, Mongo, and H2O. This will create services in the OpenShift environment for each of these ports. What that means is that it will allow access to those ports internally in the OpenShift instance. So once we, for example, spin up the runtime pod, the runtime pod can use this Mongo service to access Mongo on the server by going to the URL that's created when you expose this service. After that, we do OC expose again, but on the service, SVC is just the shorthand for service. So we're going to expose the server service, the Mongo service, and the H2O service. This will create routes in the OpenShift environment, which are externally accessible URLs. So someone will then be able to access the H2O flow interface, the server, Swagger API, or the Mongo database. So if you don't want the Mongo database to be accessible externally, you could take out this, and then it would just make the Mongo database accessible internally. The same for H2O. The server you do need to make accessible externally just for use with the Workbench, but the rest, if you worried about exposing them, you don't need to. Once we've run that, we'll have our server deployments and pods, and we'll be able to access it both internally in OpenShift and externally as well. Notebooks and Grafana. Notebooks is a Jupyter Notebooks environment and a Python server used for some of the workloads that the environment runs. Grafana is Grafana, dashboarding environment. There are a couple of things specific to OpenShift that we have to do. The first is we need to specify a specific user for the Notebooks environment. Okay, we have this 100.157.0.0.1. Because of the way Jupyter Notebooks works, we have to pre-create a user that is acceptable to OpenShift's allowed range of user IDs, and make it so that there doesn't need to be that all the work to have that user accessible and usable has already been done as part of the container build. So as we said, you've got a pre-created user in a Jupyter Notebooks environment. Because Jupyter uses the underlying environment's user management for its users, you'll need to run the pod as root to set this up. If this user isn't allowed by your OpenShift service account settings that you can create a new user with a user ID that is allowed and have that as an option in the deployment. But yeah, this is something you need to set up if you want the Jupyter Notebooks environment to work. The Python server part of it will run regardless. So another option is that you have your own Jupyter Notebooks environment and you can install our Python package. You have permissions to do that wherever you're working. In that case, you could use that environment instead of this one and just run the Python server. The second thing is our Grafana deployment is going to be using this no JWT image tag, which basically means that we're going to have to do a bit of manual work to configure Grafana to connect to the server. Normally, Grafana uses a token to access the server. In most environments, we can set that token as a secret and have Grafana automatically use that secret when it starts up, and the connection works automatically. But OpenShift doesn't like that. Doesn't allow us to do that with its default functionality. So basically, we have to start up Grafana in a more vanilla way and go in and set up the connection in the Grafana user interface and specify the token. This no JWT image tag doesn't look for a JWT token, so it then doesn't try and do all of that automated linking. So there's no issues with OpenShift starting it up. Here we have our notebooks deployment YAML. So again, we're creating ecosystem notebooks in the ecosystem environment. We also, we're using the images from Docker, which you don't want to do, but here we have our run as user. So in the container spec, you'll have your security context and specify the user you want to use. So we're going to expose two ports, 8000 and 8010. So this will be our Python server port. So this is the one that's going to run and kind of do some of the processing for us. And where the Jupyter Notebooks environment is exposed. So as I said, if you don't want to use this notebooks environment, you can still start it up and take out the security context. You can just run it up and expose this port, and that will still be accessible. We mount our ecosystem data PVC. We mount our generic data volume in the data subpath, and then we have a couple of other mounts just for our Jupyter Hub configuration. So we have our home folder, notebooks users, and notebooks we mount to app shared projects. These are specific to how we've set up the image, and will allow you to access a bunch of default notebooks that we've created that you can use to get going with the environment once you are done with your install. Once you run that, it should start as this user and then not give you any issues with permissions or anything like that. And then our Grafana environment, so you can see we've got our JWT image. We just have one port in this case, which is port 3000. We mount Varlib Grafana just to assist some of the configurations and things that we create and the dashboards in Grafana. In our ecosystem data PVC, this is assuming that you can have a read-write mini PVC. If that's not accessible, these would all probably be different persistent volume claims. And then once again, we have our C commands to take these configuration files and apply them in OpenShift. So first we have our apply. Here we just assumed you save this all in one file, your notebooks Grafana deployment. Then we need to do our two levels of exposing. So do OC expose deployment, ecosystem Grafana with the port, and then OC expose service, ecosystem Grafana again with the port. And then for the notebooks, we need to expose the two ports because we want to use both the Jupyter environment and the Python server. Again, well, I didn't actually specifically mention this, but as with the previous multiple port things, we just name them when we're exposing multiples. Otherwise, it uses the deployment name as the name for the service, which you can't do if you have multiple things you're exposing. On our 8000 port, we're exposing the Jupyter service, creating the Jupyter service, and then we're creating our Python server service on 8010. Again, that means that within OpenShift, we can communicate with the notebooks pod on these ports. And we expose the services. So we expose the Jupyter service on port 8000 and the Python server service on port 8010. And this will then allow us to access our Jupyter Notebooks environments and our Python server API using the OpenShift routes functionality. At this point, we'll have our server, notebooks, and environment set up. The next two pieces are the Workbench and the Runtime. So the Workbench deployment, we create another config map, which allows us to specify the port that the Workbench starts up on. By default, the Workbench starts up on port 80. So if all the other environments, if you're running on local, or if you do it in Docker Compose, you just go to localhost, the Workbench is there. Port 80 isn't accessible by default in OpenShift, so you need to specify some other port to use. So here we're using 8008, but the point is that you want to use something that OpenShift won't block. So this is the config map we create is an Nginx config for the Workbench. So this is our config that we create, and the relevant bits here are these two 8008s at the start. So we need to change those to be, if you want to use a different port, you would change those to be whatever port you want the Workbench to start up on, if you can't use 8008 for some reason. And then you'll have your ecosystem Workbench deployment in the ecosystem namespace. We need to mount, you'll see that to the Workbench, we don't actually mount the ecosystem data PVC because we don't need to persist anything there. But what we do need to mount is our config map. We mount our Nginx config, and that is mounted to the etc nginx conf.d path, so that when the Workbench starts up, it sees this configuration and starts up on those ports. And then we get a couple of environment variables from our ecosystem env that we set up earlier, IP, and we specify the port again. So this is the IP and port where it's going to be looking for the server. This will be your server route and the port. And then we just expose whichever port we configure here. So our 8008. And then in our commands, you'll see we just do expose the deployment for the Workbench and expose the service for the Workbench after we do our apply Workbench runtime deployment. At that point, we'll then have the Workbench, the server, the notebooks, and Grafana all started up. And the last key piece that we're going to talk about here then is starting up the runtime. Here, I'm just going to show creating a single runtime deployment. The runtime is the scoring component of the architecture. That's the piece that will be in production and generating the intelligence used for whatever you're setting up the runtime to be used for. So you'll see here we need to have a separate deployment created for each use case that's pushed to a runtime. For each use case, we'll set up a deployment and push it to a runtime. In our next version of the runtime, we're actually going to have runtimes where one runtime can support multiple cases. So you can have more than one use case pushed to a single runtime deployment. The way that you want to go will depend on the volumes that you're dealing with. If it's relatively low volume, that makes sense. If it's high volume, I think this guidance of separate runtime deployments for each use case still makes sense, and you would probably want to then horizontally scale those deployments if your volume is getting to the larger end of the scale. Depending on what your environment looks like, you may want one runtime with multiple use cases, or you may want one deployment for each use case with multiple pods for that deployment. You'll see in our runtime setup here, I'll correct that. This should not have there's two ways you can do it. What this says is we don't specify it. So if you don't specify it in the deployment, it assumes that you have some sort of auto scaling set up. The other option is you can say that I anticipate that I'm going to need however many for this case, and you kind of pre-configure the number of pods depending on your your approach and philosophy for managing that volume and how high stakes things are. So you can either specify the number of replicas here, or it could be left out completely and you use auto scaling to manage the volume. If you have multiple deployments for your different use cases, you could create runtime 2, 3, 4, 5, 6, 7 for your different deployments, and those would all sit in your environment waiting for a case to be pushed to them in a permanent in production style of managing the deployments. We mount our ecosystem data PVC and mount that to Stash data. This allows us, the main thing this enables is that we can access the runtime logs from the server. So if something goes on and we want to check what's happening, you don't have to get someone to extract the logs or exec into the pod. You can just go to the Workbench front end and use the utilities to view the logs, which is very helpful, but not a deal breaker if you can't set it up like that because of environmental constraints. So again, we mount our license key secret and then our environment variables from our config map. Here we expose a single port, which in this case, because of the port we've set in our config map is 8091, you don't need to expose multiple ports for the runtime. However, if you create multiple deployments, you will want each deployment to have its own port. You wouldn't want to create runtime 2, 3, 4, 5 and have all of them be pointing to port 89, exposing port 8091. It would work with OpenShift, especially if you have the state of what you mounted. Differentiate the names of the runtime logs using the port number. If you give them all unique ports, then it's very easy to access the right logs in the Workbench and see what's going on with the runtime. So yeah, like I said, the setup of this will depend on your use case. Do you want replicas or not? Do you want one for multiple use cases or many for one use case? Are you going to use horizontal auto scaling and then just make sure that you increment these ports if you are setting up multiple instances? And then we again use our OC exposed deployments to create the service for the runtime 1 and then expose the service to create the root for runtime 1. This will then allow it to be accessed externally so that whatever system needs to use the result of our intelligence. So yeah, those are the core components. We often use Superset and Airflow. We have kind of our own versions of the base Superset and Airflow images, but we use the Helm charts they provide to do those deployments with specific versions of the value files to make sure everything ties together and is talking to everything's talking to each other, everything's talking to the other components as it should be. But generally, Superset and Airflow would be more of a kind of enterprise level thing. So we haven't included them here as part of the quick start because I think with this it would give you enough to be up and running and test the functionality and see that everything is working. So yeah, that is deploying ecosystem in OpenShift. You see there's 15 minutes left or so. So I don't know if anyone has any questions.
Eric, on the splitting out of H2O and Mongo, it is better to split out H2O into a separate server if you're going to create a very big training job.
I think you generally want to, as your deployment becomes larger, split out as many of the components as you can because it makes managing the resources a lot easier. If you're doing a lot of model training on H2O, you'd want to have that on its own, and you can make sure you allocate enough resources for that. If you have Mongo needing a lot of storage or resources, you can split that out, and you might want to have Mongo replica sets when you get to the more kind of rigorous thing. And our default version doesn't support the Mongo replica sets. It just brings up a single instance. So I think, yeah, definitely you'd want to split that out. But I think as a quick start version, it's helpful to have H2O and Mongo spun up for you in the server. It's just a couple fewer things to manage when you're doing your first deployment.
Maybe this is the last one. Is it hard? How easy is it to move from OpenShift to Kubernetes natively?
So the two things that you have to get right, Kubernetes, OpenShift has routes to access things. It will create a URL for you and for the Workbench. It will create a URL that you can click on and send to people, and they can click on it or go to the Workbench. Kubernetes, depending on the environment and where it's running, there's no standard way of doing that. It's doable in all cases, but you have to figure out for your specific deployment and environment, how do you do that? The second thing is, and this is only an issue if you're going from Kubernetes to OpenShift. OpenShift often has tighter security policies there than Kubernetes. Obviously, Kubernetes can be configured to have whatever security policies, but the defaults are tighter on OpenShift. So if you go from Kubernetes to OpenShift, it can happen that you'll get a whole bunch of errors around permissions being denied because the default service accounts have a very low level of access in OpenShift. Going the other way is fine. Like if you have something working in OpenShift, so those are the two things. Going from OpenShift to Kubernetes, you have to figure out routes, and going from Kubernetes to OpenShift, you have to figure out access and permissions.
All right, excellent. Eric, thank you so much.